Hi kids. I'm going to walk through the covalent bonding gizmo with you. So to find this gizmo, go to our Chemistry in the Community classroom page, click from Stream over to Classwork, and here it is. You can just open it right up, which I've done right here. Then go back to this page, your ClassLink startup page, and find the Explore Learning Gizmo icon. If you click that rather than going to the website itself, it automatically logs you on. Pro tip. I found that out. So you'll go, make sure you're choosing chemistry in the community. If you have more than one science class, I'm sure you're going to have more than one gizmo thing here. So make it ChemCom and launch the covalent bonding gizmo. All right. And the first thing I'm going to tell you to do is what I almost always tell you to do. Click this and this and this. All right. So let's go to the gizmo. So here we go. We have markers again, if you remember from the ionic bonding gizmo. But this time, instead of giving or taking markers, we're going to have Frank and Flora share markers. They share the red and the blue, if you want to be more specific. And here we go. Otto and Olivia. Otto and Olivia share not just one marker each, but they share two markers each. Because covalent bonding is all about sharing electrons instead of giving or taking. So here we go. Nonmetals share. The outermost are called the valence. How many valence electrons does each fluorine have? Let's see, 1, 2, 3, 4, 5, 6, 7. Sorry, I'm losing my voice. So now it says drag an electron from left to right. So we're going to go back, left to right. So you notice now, and if you hit play, you can see it. This electron goes around both atoms. Pretty cool. Okay, and now we do the same thing, but we go from right to left. So let's do that. Pause it, right to left. Now look at, now there are two atoms circling both, or two electrons circling both atoms. All right. Covalent bonding is all about sharing. The electrons circling around both atoms means they're both sharing them. So here we go. We hit reset and hydrogen. Reset and hydrogen. Let's see. Each hydrogen has one electron, but it needs two. How can they both achieve? Well, covalent bonding is all about sharing. They can share their electrons. Here we go. It says to create the molecule. So drag one from left to right and one from right to left. This one's kind of cool. And check. If we check, we did it correctly. Yeah, we're not going to do any of this. I don't think it's too easy. I don't even see the camera button, so we'll just go ahead and leave that. So turn on show Lewis diagram. Show, what is the Lewis diagram for H2? It's right here. It's an H with a line and another H. Not going to make you do that either because it's kind of a pain in the butt. Now select fluorine. Same thing. I'll show you. So reset and fluorine. I'm going to show you, but I'm not going to grade this part, okay? So you drag one from left to right and one from right to left. And then play. You can see these two going around both. And here's the Lewis diagram. Okay. How is the formation of a covalent bond similar to kids sharing markers? Well, it's all about sharing. The atoms share electrons. How is it different? Okay, so picture two kids sharing markers and the bell rings. They probably gather up their own markers and go their separate ways. With two atoms sharing electrons, the bond between them is hard to break. That's the difference. All right, reset. It says turn off show Lewis diagram. We're not going to do that. And select oxygen. So here we go. Reset, oxygen. How many valence electrons does each oxygen have? Now let's count the dots. 1, 2, 3, 4, 5, 6. I think you probably knew that. How many more does it need to be stable? Remember, they all want 8. So if it has 6, but it wants 8, it needs 2 more. Drag electrons back and forth until it's stable. Well, we can do that. Let's see. 1, 2. Let's check and see if it's stable sharing 2. No, not stable yet. So let's do it again. 3, 4. Now let's check. I didn't click that last one. So yeah, they're stable. How many pairs of shared electrons? Let's take a look. So you have one pair there, one pair here, so 2. And we're not going to do this drawing. I know it probably makes you sad. Not doing the drawings here either. It's too much. So here we go. Valence is the amount of bonds, and the valence electrons we can count. So let's count for fluorine. Reset. Fluorine. I think we already counted this one. 1, 2, 3, 4, 5, 6, 7. Okay. So it has 7 valence electrons, and the sum is always going to want to be 8. Okay. So the valence, how many bonds fluorine will form, is 1, because 7 plus 1 equals 8. In fact, I'm going to go, except for hydrogen, it's 2. Every other one is going to be 8 for the sum. The hydrogen, we just talked about that, has 1 valence electron and will form 1 bond to add up to 2. Oxygen, we did above, has 6 valence electrons. And 6 plus what gets us to 8? 2. It forms 2 bonds. Nitrogen, let's look at nitrogen on the gizmo. 1, 2, 3, 4, 5 valence electrons. Okay. So 5 valence electrons. What does it need to get to 8? 3. Good job. Chlorine. If we pull chlorine down, it has 1, 2, 3, 4, 5, 6, 7. And 7 plus what gets us to 8? Yeah, 1. Carbon. We pull down, we can't pull down carbon on its own, but we can pull down carbon dioxide. Carbon is the black one in the middle. So you go 1, 2, 3, 4. It has 4 valence electrons. 4 plus what gets us to 8? 4. So what was that rule I kept saying? The valence of the element. The valence is 8 minus the valence electron number. That easy. So the first shell can hold a maximum of 2. How does this explain the valence of hydrogen? Hydrogen has 1. It has 1 valence electron, but can only hold 2 maximum. Therefore, the valence must be 1. Selenium has 6 valence electrons. What is the valence? So 6 plus what gets us to 8? 2. You've got this. So here we go. Noble gases, they don't form bonds. They already have 8 electrons. I'm going to say a full outer shell. And in parentheses, 8 electrons. Oh, that's it. Good job, guys. Good job.